Good day, class. So, I think today we're going to discuss about construction hazards and construction safety. Since we have already learned about different construction techniques in our course already, so I believe that we should learn this also because when you build and design your building someday as architects, we should also make sure that um, the people at the site are safe, including also uh, the surrounding community where your project will be built. Construction safety is really important. So not only should you take into consideration that you build the building on time, on cost, and in the right quality, you should also make sure that you have an excellent safety record for your project for it to be successful. Okay. So I think this PowerPoint slide I am discussing from the Institute of Occupational Safety and Health from the MPSS would suffice our objective for this lesson. Okay, for objective, so the participants will be able to identify the four major hazards of construction, discuss ways to protect themselves from hazards, learn how to select and use personal protective equipment, and apply safety procedures when working in around trenches, electrical equipment, scaffolds, and power tools. Okay, so class, if only this was a call this a face-to-face lecture, I would really ask you if you have already handled power tools. Okay? So if you handle power tools poorly, it could result to injuries also. Then when you use scaffolds, um, if you're not thinking about safety, then you could fall down from it or your uh, people at the site will get injured. Okay, so electrical equipment, that's a given. So when you handle them, there's always a danger of electrocution. Okay, so the major hazards of construction include falling. Okay, so imagine that you are working on your people are working on a high-rise building and they are on the 10th or 20th floor. Okay, and if they don't have proper equipment, then they might fall. And that also applies to you, class, as sure architects. So if you're going to inspect your project and you're not concerned about safety, then you climb the top of the building without consideration for safety, then there's a tendency that you might fall also. Okay, so electrocution, of course, you must always be careful with that. Being struck by falling objects. So in the construction sites, especially when you go high, you must be careful of falling objects. So it would get really dangerous if a hammer could fall on your head from the second story or the seventh story of a building. Okay. The next is trap during an excavation. So if you don't take safety measures, if you're going to make a deep excavation, then you don't have the proper uh, support uh, for the sides, and it might collapse. Okay, so like this one, if you dig too deep, then this area is not properly reinforced or shored, then there's a tendency for the soil to fill in. Okay, so it's really dangerous. So that's like what I've said at the beginning of the video. Um, should not only be concerned with if you finish the project on time, the right quality, should also be concerned that you have an excellent safety record. Meaning, you can you'll be really successful if when you implement a project and there are no incidents, major incidents of problems with regards to safety. Okay, so for the fall protection, so there are conditions that require this of fall protection. There are options available to protect workers. So falls are the leading cause of fatalities in the construction industry. So conditions that require the use of fall protection. So a fall from as little as 4 to 6 feet, it can cause loss of work. So it means that a person could be badly uh, injured if you fall around, I think, 4 to 6 feet, maybe it's 2 point something or 1 point something. So you fall at that height, you could really get injured. You could injure your knee, your hands. So must be careful. Or in some cases, death. If you fall, even it's 4 to 6 feet, what if there's a nail sticking from the ground, and then you fall with your head first to the nail. Okay, so it hits your brain or some vital organs in your body. So the construction site class is not it's not a playground. Okay, should always be aware of the different uh, hazards it could bring, not only to your workers but also to the surrounding environment or community. So this is the places where fall protection is needed. So in walkways and ramps, open sides and edges, holes, concrete forms and rebars, of course excavations, roofs, wall openings, bricklaying, and in residential construction. So these are the fall protection prevention options. You can add safety nets. So if you fall at a high rise building, there's a net which will catch you. You could also add handrails, safety harness like this one. Then you also have equipment guards. Then fall protection systems must be in place before work starts. Okay. This is not something class that you should use during the start of the work itself. So before the work commences, all these should already be in the site. Okay, we also have personal fall arrest system or PFAS. So must be properly trained. The key requirements is no free fall more than 6 feet and must be inspected prior to use. And safety line must be able to support 5,000 pounds. Okay, this is an example of a personal fall arrest system. Okay, then of course the guardrails also. So the top rail should be between 39 to 45 inches tall. Then the toe boards at least 3 inches tall. So this is the top rail, this is the mid rail, and this is the toe board. Then safety nets. So it is used to catch falling workers. So it's placed not more than 30 feet below working area. Then it's placed not more than 8 to 13 feet from the edge of working area. So these are examples of falling objects. So of course, you're going to require hard hats, the use of canopies if authorized, and barricade areas to prevent unauthorized entry. So you should always have this danger falling objects. So when you are constructing even a two-story residential building, you should be careful with falling objects such as hammers, okay, or bricks. Okay, I think you guys have already taken your physics classes. So what happens when you multiply the weight of the object and the gravitational constant? It's going to be a lot of force. So a fall of 6 feet or more protection is needed. Then use fall protection walkways, ramps, open sides, edges, and excavations. The next is electrical safety. Okay, this is something else that I'm really very careful, uh, even in my practice. So be careful with electricity because one false move, then it will really affect your project. So this section will discuss the safety equipment, prevention and control, the most common injuries, and personal protective equipment. So how it works is that electricity is the flow of energy from one place to another. It requires a source of power, generating station, power station, or portable generator. Then it travels in a closed circuit. So I think this is discussed in your physics already. Electricity, I think the subject is physics, electricity, and magnetism. So electrical safety, always assume that all overhead wires are energized. Okay? If you're not sure, class, then don't touch the wire or avoid it at all cost. Never touch a down power line and never operate electrical equipment while standing in water. Coming in contact with an electrical voltage can cause current to flow through the body, resulting in electrical shock and burns. Serious injury or even death may occur. Okay? So this is the most common electrical accidents and the most frequent causes. You have very contact with power lines, the lack of ground fault protector, missing ground on electric cords, improper use of equipment, then improper use of electric cords. Then electrical accidents are caused by a combination of three factors. So first, they are uh, unsafe equipment and or installation, workplace made unsafe by the environment, and unsafe work practices. So here's some of the hazards. Expose electrical parts. So what you do, you isolate electrical parts, you use guards or barriers, then you replace covers. Then for example hazard, the conductors entering boxes so shall be protected from abrasion, and all openings shall be closed to prevent access. Then another hazard are overhead power lines, equipment that could contact power lines. So you have your cranes, your scaffolds, ladders, and the scissor lift. So it's quite dangerous class, especially right now because we're using steel scaffoldings. So could you imagine if your personnel or your people working the site don't have PPEs? So it would get dangerous. Which are the most common injuries? So the direct are electrocution or death. You have shock. And you have burns. The indirect could be when you touch electricity, then you get surprised, then you fall from a high place. So, electric shock is received when electrical current passes through the body, can cause severe damage or death. You'll get an electrical shock if a part of your body completes an electric circuit, then touching a live wire in electrical ground, touching a live wire in another wire at a different voltage. Then, are the most common injuries. Most common shock-related injuries are electrical burns, arc or flash burns, thermal burns. It occurs when you touch electrical wiring equipment that is improperly used or maintained, then very serious injury that needs immediate attention. Okay? So the most common injuries are caused by involuntary electric shock. It occurs on personnel working elevated locations such as ladders, scaffolds, etc., which may result in serious injuries or even death. Then for the PPE, should always be the first line of defense. Use rubber gloves, rubber insulated work boots, hoods, sleeves, or blankets. Then for safety work practices, so only qualified person should work on electrical equipment. So it means your master electrician or even your electrical engineers. Then use insulated, special insulated tools when working on fuses with energized terminals. Then don't use worn or frayed cords and cables. Then don't fasten extension cords with staples, hangs from nails, or suspend by wire. Okay? Could also de-energize live parts before commencing work. Lock or tag out circuits. Inspect extension cords, avoid contact with overhead lines, avoid wet conditions, and check switches and insulation. So for the summary, electrical equipment must be listed and labeled, should be free from hazards, should be used in a proper manner. Then if you use electrical tools, you must be protected from electrical shock, then provide necessary safety equipment. So thing is, should take care when using electricity. So it has the power to kill. So next are trenches. So are you working on a trench or are you digging your grave? So for trenches and excavation hazards, there's a risk of excavation. So how to protect employees from cave-ins like this, and factors that pose a hazard to employees working in excavation, then the role of competent persons. For excavation hazard, the most hazardous construction operation, cave-ins are the greatest risk. Most accidents occur in 5 to 15 feet. So when you say 10 feet, that's around 3 meters plus more or less. So could you imagine, class, this is a height of 9 feet, so around almost 3 meters. If you then this is a very narrow here, very narrow gap. If you don't support this well, then this or this area could cave in and injure someone. So employees should be protected from cave-ins by using a well-designed protected system. So systems must be able to support expected loads to the system. So a well-designed system will have a correct design of sloping and benching systems, the correct design of support systems, and handle materials and equipment. So protect employees from potential cave-ins, slope or bend sides of excavation, place shields between the side of the excavation and the work area. So as you can see here, okay, for their support plus, so so that the land here, the soil here would not just erode and fill this gap. Okay, so these are examples of inadequate worker protection. So if it gets too deep like this, okay, should really be careful because there's a tendency that this might cave in or due to the pressure of the soil exerted, so there could be a landslide or erosion happening. So you should consider the factors which poses hazards to employees. Should be aware of the soil classification, the depth of cut, the water content of soil, the changes to weather and climate, and other operations in the vicinity. So these are the types of protection. This is the trench shield. So a trench shield was built around this work area. So this is here. So there's a shield protecting both sides. Then you have hydraulic jacks. So hydraulic jacks are easily dropped in place and adjusted. Trench pins installed in case of hydraulic failure. Then you also have a egress system. So a stairway ladder ramp must be present in excavations that are 4 or more feet deep and within 25 feet of employees. So it must extend 3 feet above the excavation. So these ladders not meet the requirements of the standards because this is below the excavation level. So it should be at least 3 feet above for it to work. So for excavation hazards, a competent person must have specific training in and be knowledgeable about soil classification, the use of protected systems, the requirements of the standards, and must be capable of identifying hazards and authorized to immediately eliminate hazards. So for our summary, the greatest risk in an excavation is a cave-in. Then employees can be protected through sloping, shielding, and shoring the excavation. The competent person is responsible to inspect the excavation, and other excavation hazards include water accumulation, oxygen deficiency, toxic fumes, falls, and mobile equipment. Okay, so these are the references. So these are our lesson. This is our lesson for this week class. So if you have any further questions or inquiries, you can contact me anytime. You can send a Facebook message or you can email me. So I hope that you're all doing fine. Then when you become architect someday and you start your projects, all I want you to always remember about construction safety. So think about the safety of your people, think about the safety of the community surrounding your project, and of course, you should also think about your own safety. Because you only have one life in this world, you only live once, okay? So life is quite very precious. That's why it should always be part of our parameter when measuring project success. Okay, so see you next week and stay safe always, class.